Welcome back. Just a while ago, a few years ago, we were doing a OpenShift community days, also in Zug with the meetings, we had in Bern meetings and so on, and there we met Reto. And just before the event, he was reaching out, hey Roger, I have a nice topic, Knative. And yeah, now he's here. Thank you for joining us. Reto, stage is yours.
Thank you. So good morning, everybody, and welcome to my presentation about Knative. I'm going to tell you something today about serverless, and especially the background of it, so the development in open source about that technology. Wait, that was a bit far. Who am I? As Roger already said, I'm Reto. I'm an engineer, software engineer at Red Hat, and I'm working full-time on Knative, which is an open source software. And today we're going to look into it. So I will first start out with an overview of Knative, and then show you a demo so that you can see what it's about, how it's working, and some features that it has. But the interesting part, we will also do a peek behind the curtains. So I'm going to tell you about my daily job, how we work, what specialties we have in open source development, and maybe also a bit the reality check about expectation and reality. So let's start. First off, Knative, who has heard of it? Oh, quite a few hands, that's great. Serverless as a topic. Yeah, same people, hopefully, or more. Are you actually using serverless technologies at Siemens? Yes. Just a bit. Knative? No? Lambda. Lambda, okay, yeah, AWS. So Knative is an open source solution, as already said. It's now a CNCF incubating project, and it's there to build a serverless platform, but not a vendor-specific one, but a more generic one. So you can install this thing on any Kubernetes-based platform, and it has also more moving parts. It's built out of 4 building blocks, which you can see here. First one is serving. That's the backbone of the whole thing that takes care of networking, routing, and scaling. We have eventing. That's kind of like an event bridge where you can plug in event sources to trigger your functions or your serverless applications. We also have clients and functions, and you will see those today. To look a bit deeper into it, serving is where I'm mainly working, so that's the thing I can tell you most about. That's a pretty complex sub-project in Knative. It consists of various Kubernetes controllers that interact with the Kubernetes API and also provide its own networking and ingress solution. We have special components that take care of scaling to 0, meaning your application can scale to 0 and you still can receive requests. So our components from the Knative backend will make sure that these requests are buffered, queued, your application is restarted, and as soon as it's ready, the request will be forwarded, and that is transparent to the client. So the client doesn't know that the backend actually just has restarted from scratch. That's a bit different from things like KEDA, who only take care about scaling up and down, but if you scale to 0, you will get an error if you request it because there is no one listening anymore. We also do a lot of observability stuff. We have metrics in there, additional ones that we automatically create, so you don't have to put this into your application code. And we can do all the fancy stuff with networking, like A/B deployments, canary deployments. We can do gradual rollouts or multi-version rollouts where you have different URLs for different versions, and you can A/B test your new version before the actual user sees it and stuff like that. In eventing, we have various event sources that we bridge to cloud events. Cloud events is another project of CNCF that defines an event payload, but in a generic way. So it's not specific to Kafka or RabbitMQ or whatever. It's basically just, it's like HTTP, it's formed like HTTP, it has headers, it has a pretty simple structure. And Knative Eventing takes care to bridge those sources that we support to these cloud events. So your actual application doesn't need to know anything about Kafka. It doesn't need to add a Kafka library or whatever. It can just talk to Kafka and be called from Kafka, even scaled from 0 if events occur, for example. So we have this event abstraction mechanism in place as well. Also here, we have lots of loggings and metrics around that as well. Then, obviously, we have a client. Today, each open source project has to have a client. We even have 2 clients. We have the KN client for Knative, and we have the Func client for functions. So the function client can be used standalone, but it is also part of KN. So basically, you can use Knative without functions, but you can also do it for serverless workloads like functions that would compare to something like AWS Lambda in that regard. For functions, we have in this client, we have bootstrapping mechanisms, so we can just create a function of any of those languages that are currently supported. You get a blueprint, you get a build stack, which automatically knows how to build your image, and you can easily deploy it to a Kubernetes cluster using Knative, the serving part as a backend, which would then act as that scaler for your function workloads. So, want to see it? Yes, makes more fun than just looking at presentations. So, can anyone read this even from the back? Is that big enough? Great, otherwise tell me. This demo is also on GitHub, on my GitHub, so you can try it yourself. It's based on Markdown, and it also shows the results that should be expected. So, but for now, I will skip those because obviously you'll see them in action. So the first thing we have here is we have our own YAML resources, obviously. For Knative, we have the major one is service, and that's an abstraction to easily create a Kubernetes service. And as you can see here, we only give it a name, the namespace, and an image. And we apply this with kubectl to a cluster of mine. And on the right side here, I will go to watch the pods, so we can see how it scales up and down. And we also have some internal resources. One of them is an autoscaler resource that shows the calculated amount of pods that we should have. And we can watch those 2 things, how they react when I do various things. So I will start watches here. The first one is the watch for pods. And the second one is the pod autoscalers. So can you also read those? You don't actually need to read it, but just see that stuff is happening there. Yeah, so first thing, I will just create that. And that's now applied. Knative will now take care to create pods. You can see that on the right side now. It will start those pods, that's the default setting, and it will do a health check. So we make sure that whatever you configured, the image you got me, image pool secrets, all that stuff works. Because otherwise it will be pretty bad if the first request comes in and then we start and then we see, oh, the image is not even there. So upfront we start it once, scale it, see if it gets healthy and if it responds to requests. And if that's fine, after some time, so I have to talk a bit longer now, you can already see it's in terminating state. And at some point it will go away. And down here you can even see it has no traffic, so no requests coming in, so it's scaled to 0. Current cluster usage for my application, nothing. Not nothing, I need a few etcd resources. There's so some storage space for etcd I'm claiming with my application, but I don't claim any memory or CPU in the runtime. What's happening behind the scenes? We are still using Kubernetes, right? So we have created several Kubernetes objects. One of them is a deployment, which creates a pod. But we will automatically scale those deployments up and down as needed. Down here in the Markdown, you can find whatever you create. I will show it here. Let's make that a little bit bigger. So there is this cool plugin for kubectl called Tree, where you can see all the resources that are created in a hierarchy. So here, maybe even a bit bigger. No, not bigger than. Let's keep it that way. So the top one is the Knative service. And then down here we can see a deployment. So we created a deployment out of it that creates a replica set and no pods because we're scaled to 0 for now. But we also have lots of Knative internal objects like this pod autoscaler, metric, serverless service, and stuff like that. These are our internal resources that we use for different functionalities, different features, configuring routing and networking and stuff like that. And down here we can even see we create not just one, we create 3 Kubernetes services behind the scenes for various purposes. So the developer actually doesn't have to care about all these YAML things. That's the idea. You just give Knative the definition of what you want to run in as simple as possible way, and we take care of it. We have lots of defaults in there, lots of stuff that over the years accumulated in knowledge that's now in code. So we do a lot of stuff behind the scenes. And if you know it better or have specific reasons to change them, you can override everything that you could do in a normal deployment as well. So just briefly, up here we see the deployments that it created out of that pretty small service. And just you can see it already has a lot of stuff in there like readiness probes, liveness probes, and things like that that we add to the deployments behind the scene. Okay, let's do some scalings. The default Knative setup has some configuration that is built for robustness. So Knative scales up based on a window. During that window, it analyzes how many requests come in, and it decides if it needs to scale up or down or whatever. For demo purposes, these are a bit long, so we will make Knative a bit more aggressive with these config patches here, just that we don't have to wait forever until something happens. Okay, we're already watching it here on the right side. So the first thing that we've seen is scale to 0. We actually already have seen that, right? It scales to 0 if there are no requests. What happens if I send a request now to that service? If I do the curl down here to that service, as you can see, it took a while. Oh no, that's the wrong name. Sorry, I need to apply it first maybe. Interesting. So let's do the other one then. We already have the hello world. That should work. May the demo gods be with me. Oh yeah, great. So
now we know it's a real demo.
Yeah, it's a real demo. If the speaker gets nervous, then it's a real demo. So now we got the hello world down here, and on the top right corner you can see we got now that hello world pod, and right now it decided to also create the other one. Thanks. So now also this one should actually work. Scaled to 0. Hello Siemens folks, great. Yeah, and as you can see, it's scaled up. It already scaled one of them down again. And yeah, if we wait a little bit longer, all the pods will be gone again. So as I said, per default, we will always scale the service initially to make sure it's working. Obviously, you can override all our configurations that we have. So there are special annotations like this one here, auto-scaling Knative def. And we can tell Knative that we don't want to scale initially. We are rockstar developers, so everything I configure in here will work from the beginning. I don't need to check it. So I will actually just create that one here. And yeah, now it's faster, that's good. We can see scale from 0 has now a desired scale from -1. That's just, it's not set. So the autoscaler does not know yet which amount of pods it needs. So it says -1, then we don't get any. And now we can call it, and it will scale from 0, which actually means it will now start pulling the image it will take a little bit longer because it needs to get the image first. And in the other way, we already at least pulled that image to at least one worker node, right? The pod already started once, so the image is somewhere. We also have some magic stuff that will make sure that the image is in all the worker nodes in the Docker pool so that we don't have to wait for the image pull. But that goes a bit too deep. So what else can we do? We have different targets for scaling. Obviously, we can also use the HPA, so we can scale on CPU and on memory. Usually, that's not the best idea for various applications because, for example, I don't know, Java uses a lot of memory, but not a lot of CPU. And CPU is maybe not the best metric for scaling, right? A way better metric could be concurrency. Maybe you did a load test on your application, and you know my application can handle, I don't know, 100 requests per second or requests concurrently, and no more. And if it's more than that, please add another replica. So here we can say I have a concurrency target of 1, meaning my service can handle 1 request at a time, not more. Also initial scale 0, we will create that service here again. And now it's up to you. Let's wait until it's created. In the meantime, I created target 1 request can my service handle. And I will create 1 request with this curl here. How many pods will I get? Who said 2? You have used Knative before. That's why 2?
Because you have 1 in the request.
Yes.
And you have to have a second one to handle the next request.
Yes, he said I have to have another pod on hold basically for the next request. That's exactly what's happening, right? I create this, I get 2 pods. That's a bit counterintuitive for most people. But obviously there is a setting. So Knative also needs to make sure the next request will work, right? And our default setting is the container concurrent target percentage, and default is 70%, meaning from whatever you tell me, we make sure that we only use 70% of that, meaning for 1 request with target 1, that's not enough, that's not 70%, so I need to have a second one. Then I have, I don't know, percentage, some more than 70. If I put it here on 1, that would mean it's okay to go to the limit. If I have target 1 request, don't scale more. The next request will need to wait for the next pod to come up. So if I set that one and do it again, we only get 1 pod now. You can do that with Knative, maybe not the best idea. Yeah, question?
It's showing 2 out of 2, so is that coming up with a sidecar? Is Knative providing a sidecar for that? Or is that just you got your own, something else running as a sidecar?
Exactly, that's exactly right. We have this component here that's called kubeproxy, and that's part of each pod. And that actually takes care of metrics and observability stuff and encryption stuff. But yeah, we have a sidecar, that's why there's 2 of 2. Okay, great. So next question. We now scale this 1 targeted service to 20 concurrent requests. So hey here does 60 seconds of load with 20 concurrency. How many pods will we see?
Currently 20, isn't it?
20. Let's see. So we have desired scale 18 for now, actual scale 12, so it's scaling up now. Why not 20? Because concurrency doesn't mean these requests all take the same time, right? The hey command sends 20 requests out, but it can be possible that one service is really fast in responding to one request and can take the next one, right? So the queue is actually never full. So Knative doesn't need to scale to 20. It can handle it with 18 because the services are really fast. If the services would be slow, then it would scale up more. Yeah, in 1 minute we will see the results. We have, I don't know, something more than 2,000 requests per second now. So these services are pretty fast. So scaling is tricky and needs tuning, as always. It's not just out of the box, totally logic. You put 20 here and then you're fine. Okay, how much time do we have left? That should be enough. Let's do a quick function demo as well. I will delete the existing services just that we can see. So I will now use this func.cli to create a Golang function. And we can see it creates a blueprint here. We have this Go mod file, and I have a handle.go function that has a body for a function. That's pretty what you should know from AWS Lambda, maybe Node.js, whatever, but you have this envelope here. Then we can build this function. This will take some time. So behind the scenes, Knative function is using Paketo build packs, and we have language packs for different languages so that we know how to build stuff, how to get dependencies and stuff like that. So here, this will take a while, as said, builds a Docker image, but I don't need to define the Docker file, right? I don't have a Docker file, container file anywhere. I just take care of my Go code and build a function here. And if it's done at some point, I can then func deploy on it. It will deploy it to the Kubernetes cluster and create a Knative service out of it. So what I showed before, these services, these were just not functions, these were some other services. You can run any workload on Knative. You can even put Spring Boot or whatever in there. What is good, if you want to go serverless, is if it's a fast startup and it has a fast response time, because otherwise the user will wait longer for the first response to be there when you scale to 0. So, but you can basically put anything in there. We also don't have any restriction on memory and how long the function or the service can run and stuff like that. It can run forever. It can take as much memory CPU as you want, depending on your cluster. So, handshake broken, that's good. That might be interesting. Let's try again. Otherwise, you have to believe me that it would say what it's in the text here. The Wi-Fi is hopefully open, right? There's no TLS proxy in there. That's a good thing. Let's do continue on the slides. We'll get back to that. So where were we? Demo time. So there is way more stuff in Knative. As we only have 20 minutes left, I cannot tell you all about it. It's definitely a good thing to refer to the documentation. As said, I haven't shown you tag-based routing or canary deployments or stuff like that. We can do way more there. Definitely interesting to try that out yourself. But now, the interesting part behind the scenes of open source development. So maybe not super behind the scenes. Yeah, imagine you were told by your boss tomorrow that you should do something on an open source project, right? He comes to you and say, hey, go, that project is open source, right? Go there, add a new feature. And yeah, obviously your reaction is, finally, I heard it before somewhere here, you have fancy VPN clients. You don't need VPN because you can go to GitHub, create a fork, git clone, hack, test it locally, everything is fine. Git add, commit, push, done, right? It's open source, it's GitHub, easy. Yeah, maybe not. The reality is a bit more complex, especially in bigger open source projects where you have a lot of community, a lot of repositories. For Knative, for example, we have in our main org, that's Knative, we have 31 repositories, and all of these are huge. And all of these are interconnected mostly. So it's not just one, you clone that and you're done. It uses another one that has a dependency on that one. Then we have Knative Sandbox, which we now want to rename to extensions because it's not really a sandbox. The production product is actually using stuff from Sandbox. So we have 50 more projects in there, which also are pulled in, as said. You also need to know some of them, check them out, go through the code. Okay, we got that. Now let's go through serving. Serving, as I said, the backbone of routing, scaling, and stuff. Here on the right side, you can see the tree. We have more than 2,000 directories, more than 7,000 files of Go code. Yeah, you need to understand that repository, the domain of it. You need to go through the paths through these share components. obviously also need to understand why is it the way it is right now. Then you look for documentation. That's probably outdated, or it's for the end user. There is a docs folder in the root of that repository which contains stuff that is not in the code. So, okay, hopefully you have a README which tells you how to set it up, and that's still accurate. Otherwise, please do a PR. Yes, and so you need to go back, go to the people that have done it, see past PRs for reasoning about the sources and stuff about that. And just 2 examples out of here. I did a quick link. So I did this initially for Knative Serving. And you don't need to understand this here, but each of these bubbles here is one Kubernetes controller inside of the Knative controller, which we have many of. So it shows the dependency chain of the actual objects and controllers involved and how they interact and what they create, and then another one reacts to that. So it's a hugely distributed event-driven system with decoupled components, and all of that is inside one process. So we cannot just debug it through and see what's happening, because you write something back to the Kubernetes API, some watcher fires, it triggers another controller that does something else, and that runs in a separate Go routine. So it's even hard to understand what's happening in one repository. And we have lots of components that are deployed in multiple deployments with multiple controllers each inside them. The second thing is the object chain. That's kind of, we've seen the tree before. That's a more detailed view of that. So that's how our objects correlate and how they depend on each other. You need to understand that stuff to make bigger changes to the project, right? Which makes it kind of hard. Okay, that's fancy. Let's do it here. Why doesn't that work anymore? Okay, great. So one more thing. Planning in open source is chaotic at times, especially because we have not a single team or a person or even a company responsible. So it's a collaboration of multiple companies with different interests, different timelines. We have people that started work but no longer contribute to the project. So there's one example down below. We have some issue from 2019. Some guy started working on it, and 6 months after, someone asked, hey, are you still working on that? How is the status? People are waiting on that. And yeah, obviously he did never respond, and some maintainer then decided to reassign the work. But yeah, we have now 2023, and that specific issue is still open. So it's not just you put something in there and it will magically work. It needs work. You need to be behind the stuff that you really need. You need to push it. And if you want to change really to happen, you have to do it yourself. As I said before, if the README is wrong, if the setup is broken, do a PR to fix it. But you have to do it. It won't happen automatically. To make that easier, we have from CNCF and also from that whole Kubernetes community, we have some organizational structures that should help with that. One of them is roles. So it's not just that you start at Red Hat, you get admin access to the repo day one, and then you're ready to go, as in normal companies. We have a role concept. So first you have to do contributions like anyone from the random internet, right? And you have to do 50 of them, I think, and at some point you get the member role. With a member role, you get access to the design documents of the community. So that's not a Red Hat thing, that's the community work. And then you have to do several reviews and do PRs and do bigger PRs. And at some point you can go for the approver role. That would mean merge permission. An approver can actually say that's good enough to go into the project. He also gets this on the GitHub organization, but it's limited to specific directories. So it's not just you get approval rights to whole Knative. You get it to specific subrepos or even subfolders, where you have shown that you are mature enough to review stuff and to change stuff in that system. Then at last we have the working group lead. That's basically the person leading the whole effort on a specific area. That one also has to triage issues, prioritize stuff, and help new contributors with mentoring, label issues that they are good to start out, stuff like that. We have several working groups. as you can imagine, we have working groups for the serving and the eventing and stuff like that, but we also have stuff like productivity, operation, security, which take care of these specific areas. They have weekly or bi-weekly meetings that are recorded and have public notes, and anyone can join. So it's open. All the users, all the contributors can join, ask questions, and collaborate there. One also important part is Knative is also a specification, not just an implementation. It's the default implementation, but we have other ones like Google Cloud Run is based on the Kubernetes specification. And we have a whole set of conformance tests that prove that you are conformant to the specification. So we ourselves have to comply to those tests, but also other vendors have that. We have also multiple networking implementations. We can work with Istio, Courier, Contour, and all of these things have to run the conformance test to comply to the Knative networking specification. And all of that stuff runs in every build. So I will get to CI now, because I think that's also interesting from a corporate perspective. We have a lot of build tasks that are shared across all of these 70 plus repositories. As you can see down here on the right, we have on serving, we have to pass 60 or roughly 60 checks on each PR. We will run a lot of end-to-end tests on a matrix of Kubernetes version, the networking layers we have, and then also mesh and non-mesh, TLS and non-TLS cases. So all the tests are executed multiple times on various versions of Kubernetes, various versions of each ingress layer to make sure everything is still working. And we also do cross-repository tests. So if we change something in one repository that is used in other ones, we usually have tests that we basically build and test the other repository with changes that happened here locally. And with these processes, we can make pretty sure that stuff does not break. Obviously, it still does, but if it does, we will add a test to prevent that in the future. And just to give rough numbers, serving alone has around 3,000 unit tests, and I think more than 400 end-to-end tests that really create a cluster, deploy Knative, create the service, scale down the service, take away the registry, restart the service, see what happens. All these things are orchestrated, and they happen on any commit. So any commit from mostly anyone has to pass all these checks before even someone will take a look at the PR. I said these run all the time. No, they don't. You need a label OK to test from a maintainer, reviewer, approver, just to make sure that not anyone can open various pull requests, and we spend a lot of money on CI for that, and it's actually based probably spam or whatever. That's CI. So now pretty sneak peek into the Red Hat parts in this. So everything I told you up to now is the Knative open source part. Red Hat also has a product on that, but that's also open sourced. And it's basically Knative, right? It's a fork of the upstream repositories that we need. And all we do in there is we patch it to make it run on OpenShift, more or less. It doesn't have additional feature or anything. And if we can bring something into the upstream, so into the Knative one, we always try to put it in there first, because it takes maintenance burden away from us, but also everyone can profit from these changes. We have a GitHub organization that is called OpenShift Knative, which, as I said, just forks the Knative ones. And I can tell you a bit about this pipeline. We have upstream, we call that upstream, that's Knative. That uses GitHub Action, Prow, and primarily Kubernetes from Google, or as I said, the kind one, so local in GitHub Actions directly. Then we have this fork that is also on GitHub, where we apply Git patches. So we check out the code in different branches, put Git patches over to make it run on OpenShift. One thing, for example, is we cannot run as root in OpenShift, so we have to take different users here for OpenShift. That's in a Git patch, for example. Then we also do backports and bug fixes that we have to do for our customers on the midstream part, so here. And then, yeah, Red Hat doesn't has different stuff. Like we have also to bring in OpenShift here. We have Koe.io that we use for Docker images and not the Google Container Registry. But setup pretty similar to the left one. We try to align as much as possible to that one. And then for the bits that you as a customer actually get in your clusters, we mirror that whole thing to internally. There we have GitLab, just to add another tool. We rebuild everything using Jenkins. And then sign stuff and distribute to CDNs and stuff like that. But as you can see, we have a whole zoo of tools in here. And what's the common ground for all these CI tools? Because all of them have proprietary definitions for builds, right? What's the common ground? Bash. Yeah, that brings me to my personal summary of that. So it can be chaotic, especially in planning, but overall it's really rewarding. Community is super welcoming, open. You can talk to everyone. You can call them, write them all the time. Slack is key. That without that we will be lost. We would be lost. It can be hard to start, especially in a bigger project if you've never done something. So look for guidance. Look for the good first issues. Also mentorship from the maintainers if possible. For us as a maintainer or community, it's very important to have good documentation that is up to date, that we have readmes that work, stuff like that, and yeah, open communication overall. Then what I personally learned in comparison to enterprise development, where you want to go to that full end-to-end test and stuff, but you obviously never really achieve, the open source world really depends on that. We would not be able to maintain the project without having so good tests. We invest really a lot into that. And then you can make changes, also automated changes, and be sure that they work in the end. And that works really good. And so we also can have the same build definitions, roll them out across all the repositories, and the next build on main will not break. Or if it breaks, we will get feedback really fast. Then Bash is pretty common. I wasn't a huge Bash user before, but I have to now. It really helps to automate stuff, to have a common ground for various CIs. It will run locally, more or less, depending on your OS and versions of binaries and stuff, but you can make it somehow. And the last thing is the Git patch approach is actually pretty good if you have to use sources but cannot change the origin, right? For some reason. So it's good to have Git patches because they give you, it's not type safety, right? But if something changes on the original code that you clone and then apply the patches, it will break. Because something, even if line numbering changes, the Git patch breaks and then you need to take a look and fix it. So we can use that to change code that you don't own. But you can also do pretty hacky stuff with it. And yeah, as it's written here, we can talk about that over beers and not over the camera. Okay, and now before we go to the question, let's see if that actually is back up running. Yeah, now it built it. Great, whatever that was. So let's do a func deploy just to finish that demo. And that will now actually upload the build image to a registry. Hopefully that it's Quaio, so it's going to the internet and back. Okay, in the meantime, any questions?
So we have a few questions from the audience, from the remote audience. So here's from Anil, a question for beginners. What is the difference between Knative and container or workload orchestration?
The difference? It's basically, how to say this, it's on top, right? It adds stuff to Kubernetes. Under the hood, it's basically the same. It takes what Kubernetes provides and adds more features to it. But we are using the whole Kubernetes, whatever it does, down the hood. So it's not really different, it's an addition.
Good. And we have another question from Andreas. Do you suggest the use of Knative for real production stuff?
Hopefully, otherwise I wouldn't be here, right? Maybe it's not the best idea to put your really fat legacy system into a function, But if you're designing new stuff, especially in the event-driven, decoupled world, it's a really great approach to use Knative. As said, you don't have to use a function that is really small. You can also put your Spring Boot or Quarkus or whatever service in that and benefit from the additional features that it provides. So yeah, I would definitely recommend it, and we have lots of customers that actually do that. You obviously do that as well, right? Not with that product, but the principles.
With 3,000 tests, unit tests, and 400 end-to-end tests, how long does it take, the whole test cycle?
It really depends. On the open source stuff, it's about 20 minutes, I would say, with cluster creation and stuff. When we go to the OpenShift path, where we have to install way more, also we have Istio integration, so service mesh and stuff like that, we get up to 4 hours. I think that's the longest build that we have. But that does these tests, I said, these are just for serving. We have this for every repository. On the OpenShift part, we then do a whole test suite across all the components of Knative, and that takes roughly 4 hours.
Well, I don't really understand the use case, when to use. So sometimes we have lots of debate between serverless and container, right? And some say, hey, let's go serverless. We don't need to take care about Kubernetes. And here we go serverless, but need to understand Kubernetes. So the others say, let's go just container. So it seems that using Knative, I need to understand both. So it's more complex than either decide for one or the other. So what's the use case? When would you recommend to use it?
Basically, it depends on your strategy as a company, right? You can say, I go all in AWS, and then I obviously can use Lambdas because that's the serverless part of AWS. But if you, like most bigger companies, go to a multi-cloud approach, you don't want to go vendor lock into one specific solution. And Knative actually provides an abstraction that works on all the Kubernetes. You can also use a managed Kubernetes from Google or whatever, so you don't have to take care about cluster administration. And to install Knative, I think if you don't use SaaS Kubernetes, you always have a team that is responsible for your cluster, right? But not all your developers need to understand Knative. They can, not Knative, sorry, Kubernetes. They can just use Knative, the abstraction part, and one central team maybe takes care of Kubernetes and installing Knative. But if you are in a public cloud and all in there and have no problem with going the proprietary way, you can also use the one that the cloud provider provides, obviously. And maybe question serverless and not serverless. Serverless is just saying you don't need to maintain your servers or whatever is below deployments and stuff like that. It's just another abstraction. In the end, it's just containers. It's a container image that runs as a function. So it's not container or serverless. It's just a different deployment model where you have to take care of less responsibility.
Perfect. Thanks a lot, Reto, for joining us.